Hey guys, Mr. Nakmi here. Ready to start off a new section today. Unit 6, Lesson 2. Hopefully, you guys are ready to do some problems again. Today, we're going to be talking about constructing confidence intervals for a mean where our samples are too small. Our sample size is too small, right? It's going to be less than 30, our sample sizes. Now, last section we did this. We did it for sample sizes are greater than 30, or we knew the population standard deviation, right? But in many real life situations, the population standard deviation is going to be unknown. It's one of those things where we wish we could know it, but it's just not possible. It's just too large to calculate. There's just too many people in the population to calculate the population standard deviation, right? And things like time and money can't be put into that, and it just would not be practical to collect all of those sample sizes, or even sometimes not practical to collect sample sizes of 30 or more, right? And for you to do your z distribution, your confidence intervals with that, you need it to be a nice bell-shaped curve. But sometimes that's not the case in the real world scenario. We can't do it for every single one of them. So what happens when we get something where we have a sample size that's less than 30? Well, how are we going to construct such a confidence interval for that when you have such a small sample size, or you don't know the standard deviation of the population? Well, today we're going to go over that, right? We're going to be using this thing called the t-distribution, right? The t-distribution. The t-distribution is when the population standard deviation is unknown and the sample size is less than 30, and the random variable is approximately normal. Approximately normal. It doesn't have to be exactly normal, just approximately normal. It follows a t-distribution where it equals to this equation here. And it's kind of, if you look at it, it looks kind of similar to your z-score, doesn't it? It's just a little bit off right here, okay? Now, we're not going to be using the t-score per se in this section to construct a confidence interval. What we're really going to be focusing on is going to be this guy over here, which is t sub c, or t critical, right? And it sounds similar, but that's because you guys did this last section, right? Z critical is the same idea. It's the critical values, right, that will help you to calculate your confidence, your margin of error, which will then help you to calculate your confidence interval, okay? Before we do that, though, I got a couple properties here for you that you guys need to type into your notes. Okay, hopefully you're following along and you open this up on Canvas and you have these notes open. First one up, the mean, median, and mode of a t-distribution are all equal to 0. Okay, the t-distribution is bell-shaped and symmetric about the mean, kind of like the z-score, the z-table, right? The z-distribution, the normal distribution. It's kind of like that. The total area underneath the t-curve is 1 or 100%, just like the z-curve, the normal curve. 4, the tails in the t-distribution are thicker than those in the standard normal distribution, right? When you look at the t-curve, and I'll show you that in a second, the tails of it doesn't actually get really close to the axis like it does in the standard normal distribution. Next one up, the standard deviation of a t-distribution varies with the sample size, but it is greater than 1. So the sample size that you have for your problems is going to make your standard deviation vary from problem to problem, right? Number 6, the t-distribution is a family of curves, each determined by a parameter called degrees of freedom. This is a big one right here. Degrees of freedom are the number of free choices left after a sample statistic such as is calculated. When you use a t-distribution to estimate a population mean, the degrees of freedom are equal to 1 less than the sample size. To keep it simple, basically, when you're doing a t-chart or a t-distribution, you need this number. You need this degrees of freedom, right? This df right here. And it sounds complicated, but all you need to do is take your sample size and subtract 1 from it. So if you have a sample size of 20 people, your degrees of freedom is simply 19, right? And that's all that it is, right? And all you're going to do with it is actually use it to look it up on a chart to help you find your critical value, okay? With a t-distribution, right, it looks something like this. See, the standard normal curve is this blue one right here that bends along the way, and then if you draw it all the way out, it kind of flattens out along the axes on the left and the right hand side. Now with your degrees of freedom though, if you have a degrees of freedom of just 2, you see how it's still symmetric about the mean, but you see what I mean by the tails being thicker? It's raised up off the axes a little bit on both sides. And as you increase your degrees of freedom, it lowers that tail. It gets closer and closer to the standard normal curve, right? And that's why when we get to about 30, 31, 32, it ends up looking practically like the standard normal z distribution, okay? All right, enough with all this talk. I'll show you how we actually do this. Today, though, we're only going to be starting off with just finding the critical value, t sub c, and we'll continue with the rest next time. So today, we're going to keep it simple here. So you guys know when we dealt with all those z-scores, I always asked you guys to go find the pink sheet that was laminated, right? And I told you guys don't call it that when you go off to college, right? It's only pink in my class, and all your other classes you're going to call it the z table, right? Now, for this section, we're going to be looking at the t table, and I'm so sad that you guys aren't in class for this, but I would be referring to the t table as the blue chart, right? I have these made and laminated with blue, so you guys could be able to tell the difference. Oh, this is a blue chart problem. This is a pink chart problem. This is going to be your t table problem, right? And we'll talk about how would you distinguish if it's a z table or a t table later on, but just giving you a heads up right now. It looks something like this, right? It's a t distribution, and if you look at the file, it's on page 18 of the appendix, right? Your z table was on page 15 and 16. I'm sorry, 16 and 17, I should say, right? So your t distribution looks something like this, right? It's far less numbers compared to your z table, okay? Right here, you'll notice we're looking for level of confidence, right? Right over here. Yeah, here. And they have a level of confidence of 50%, 80%, 90%, 95, 98, and 99, and that's going to be in the middle here, your level of confidence, right? Your lower and your upper bound, which will be caught in between your negative t and your positive t here. So this will help you figure out what your t critical is. That's all these numbers in here. So once you find out which one it is, level of confidence you're dealing with, all you need then is your degrees of freedom, and your t critical is just going to be the number that corresponds to that, okay? So if I go ahead and take a look at this problem right here, they're asking us to find the critical value for 95% confidence with a sample size of 15. So let's write that down. Our confidence, whoops, let's get the pen out here. So our confidence level in this problem is 95%, right? And our sample size, n, is equal to 15, okay? Knowing what our sample size is, that tells us that our degrees of freedom, remember, is just equal to your sample size minus 1, which in this case is equal to 15 minus 1, which is equal to 14. That's what your degrees of freedom is. Degrees of freedom is 14 with a confidence level of 95%. All I gotta do now is look on my chart and see, oh, I'm looking for confidence level of 95%. That's right here. That's going to be all of these numbers down here. And my degrees of freedom is at 14, which is over here. So that is terrible. Got to do a better job there. 14, and it goes all the way to here. And my critical score then, my T critical, is going to be equal to 2.145. And that's it. That's how you find your critical score using a T table as opposed to a Z table, right? When you look at a Z table, which was on the one on the previous page before, where they had level of confidence right here, 95%, right? And the Z critical score was 1.96 for 95%. And you'll say, that's not the same number. This is 2.14. The other one was 1.96. And that's the thing. When you do a T critical, if you look at the T chart, and especially if you're looking for 95%, which is down here, if you're looking at 95% and you start going down here, look at the number of this thing as we increase your degrees of freedom. Right now at degrees freedom of 14, it was 2.145 as your T critical. As you start to go further down, I did not write on that. Get out of here. Right? As I start going down, right, you'll see this number starts to decrease and it starts to get closer and closer to, what's that number? 1.96. It's the same concept as what we were doing with our Z table, but now what the T table does is it allows us to approximate these critical values so we can calculate our margin of error with numbers and sample sizes that are less than 30. Okay, let's do one more. All three of these will be for you try. You guys will actually have to type out the answers for these, but I'm going to give you one of them if you watch the video all the way through to here, and you'll see how to do this. So let's say it was asking to find the critical value T sub C for confidence level of 90%, right? And my sample size, N, is equal to 22, right? With that, that tells me that the degrees of freedom in this problem is equal to 21, okay? So I have a confidence level of 90% with the degrees of freedom of 21. I'd simply go to my T-chart, and I'll have the T-chart in Canvas for you. So you guys, well, actually it's already there. You guys already know that page 16 and 17 is your normal distribution. Just go to page 18, and that will tell you how to get, that will give you the chart that you need to look up, okay? So back to the problem here. My confidence level is 90% with the degrees of freedom of 21, so 90% is right there. And degrees of freedom is 21, which is right here. And that tells me that my Z critical is 1.721. And that's it. That's all I gotta write down. My T critical is 1.721. And that would be my answer for this problem that's asking only for the critical value. Right, so for these three problems, right, I want the answers for you to type in, and I'm already giving you the first one. Look up the other two, give these a shot, and that's gonna be it for today. We're gonna try to break this down a little bit slower here. I heard that some of you guys are stressing out for doing all these online classes for 8 classes for some of you guys, and some of you guys have some AP classes, and it can be a little overwhelming. Go ahead and give this a shot if you feel like this is a good amount for you. Let me know when you turn this problem in. Put in the comments saying this is a good amount. If it's too easy, let me know as well if you want me to do a little bit more. Other than that, hope you guys are keeping healthy and staying safe. Hopefully get to see you guys at some point before you graduate. Aside from that, have a good rest of your day. I'll see you later.